Hi, my name is Ella Hoeppner. I'm a generative artist from Virginia. My background, I come from computer science. In the past, I've worked as a software engineer, and I've had a love for programming, and especially the creative side of programming in software since I was a kid. One of the first things that I did when I learned how to program was to create generative art with processing. I would create, desktop backgrounds and animations that I would show to my friends. And that was really what got me passionate about programming and computer science in the first place. So yeah, I've had a background in those things for my whole life.
Most people find processing after they've had this computer science background for so long. How did you find processing first?
Gosh, honestly, I think what it was I was trying, or I was in high school, and we had like laptops at our high school, and they were pretty locked down, and it was restricted what you could do with them. But I managed to get the processing IDE to work on one of those laptops, and it was nice because it was this self-contained thing. I only needed the one program, and so really I got kind of forced into it because I needed just one unified development environment that I could work in. But I'm really glad that I did because it was a really wonderful way, first to just learn programming. I learned so much about computer science in general just by playing around and processing. But also, it opened up this whole, artistic practice that has been with me my whole life.
That's awesome. So you like hacked the system.
Yeah.
From processing.
Hacked the system just so that I could do generative art. Started with processing. I've used P5.js plenty. I've also done work with a Python, creating like SVGs. But now my main workflow is working with WebGL and writing shaders. And so I just kind of do that with a custom library that I've written in a language called ClojureScript. And so I have a very like functional programming shader oriented way of doing my art now.
I would love now to turn to Truth, to the exhibition curated by Adam Berninger. The show is about exploring our perception of scale from the microscopic to the cosmic, where artists are using various abstract forms to look at the fibers of our universe, either obscuring/uniting the differences between the micro and the macro, and inviting a perceived sameness across the scales. So when Adam approached you about the show, what resonated about this with you?
So the piece that I'm contributing, I think it very much fits with this in the sense that it's easy to look at it as sort of looking like some large like cosmic event, like a supernova or something like that. But it can also be seen as something like much more kind of at a human scale or smaller, something microscopic. I'm definitely playing with kind of the varying perceptions of like the time scale that it's playing out on and the different size. And it's meant to be kind of interpreted as many different things. I don't have a standard process. But often, and for this piece, I did start with a sort of a technical idea first. And I was playing around with something called a force-directed graph layout, which is this idea in data visualization and computer science. And I just, I figured that there was something in that kind of practice, the graph layout algorithms, to be used in sort of a purely aesthetic way, not really trying to visualize any sort of data, but just exploring what these kinds of systems can do from an artistic perspective. And so for this piece, I very much started with just the sort of technical idea and found a way to turn it into something beautiful and aesthetic along the way. The basic idea is that you have some nodes and connections between those nodes, and the system kind of figures out the right way to place all those nodes based on their connections. And so aside from that, how the edges are drawn, how the nodes look, all of that is very much up in the air. And so I've made a lot of specific decisions about how to visualize that for this piece.
So can you tell us a bit about those decisions and sort of what you were weighing against each other and what brought you to this final work?
Yeah, there was sort of the choice of, should I just draw the nodes? Should I draw the edges between the nodes as they're moving? Should that all sort of be visible the whole time? Should some of that fade away? And so what you see in the final piece, there's a few different modes in which you see like all of the edges kind of being drawn out and staying on the page the whole time. And modes where you just see the nodes that are kind of guiding the edges, but you don't see the edges themselves, and you just see these long strands, these threads, like that get drawn out over the course of the piece. And there's also modes where the sort of trails left by the nodes will be dotted, where some of them will turn on and off at different times and have different colors and different parameters in different locations in the canvas.
The color palette is so striking. What were some of the choices that you made, or how did you kind of come to those?
Deciding on color palettes is always a very interesting process. I often have a different way of approaching it for every piece. For this piece, I just sat down and took a lot of looked at art pieces of art that I really appreciated. Some paintings, some other generative pieces. And kind of took ideas from those, played with them in image editors, and found out like which specific pixels do I really think have a color palette that I really enjoy, and played with those, played with different levels of saturation, and came up with a good variety of different palettes to use in the final piece.
I'd certainly say so. I'm wondering, if you were to describe this piece to somebody, how would you describe it?
I guess I would describe it in the technical way, really. I would say I'm using a force-directed graph layout algorithm to create something new and interesting that hopefully is like nothing people have seen before.
Generative art gives the opportunity for more of these like very technical kind of approaches to art in a way that wasn't always so transparent until now. And it makes it such an interesting time to be an artist, I would think, to be able to express yourself not only aesthetically, but in a mathematical way. How do you see yourself sort of in this balance? Is it a balance at all? How do you, as a generative artist, if you'd even call yourself that, or as a computer scientist?
Oh, I definitely call myself a generative artist. I think that's definitely how I would identify. I think that's a really great question. And I do very much look at things from a technical perspective, but always with the end goal of creating something that is aesthetically striking. And I sort of see generative art as a very exploratory process. Like there's this whole universe of sort of undiscovered and untapped mathematical potentials. And I kind of see myself as like an explorer trying to find something radically new that nobody's ever seen before, and bring that into the world so that people can appreciate the beauty of, abstract mathematical structures.
Do you think the code itself is beautiful?
Very much so. And I think that that part is a bit harder to appreciate, I think, for a lot of people. But for me, when I think back on my pieces, the code and sort of the math behind how a piece is defined is just as important as the final aesthetic result.
As someone who came to this practice from the generative art, or came to the computer sciences from the generative art angle, who are some of your influences?
Oh, sure. So I would say one of my big influences originally was Jared Tarbell of Inconvergent. A lot of his pieces were super striking, and some of the first generative art that I saw that really inspired me. I'd also say Seifert, of the founder of FXhash, especially his work with particle systems, has been really, really influential on kind of my style.
You mentioned particle systems in your bio. Would you mind going a little bit more into that?
Sure. So when I say particle systems, I just mean sort of any system where kind of the structure is defined by a series of points in some space, and it consists of a visualization of how those particles move around and interact over time. So in this piece, mainly what you see in the piece is a series of lines, in most of the iterations at least. And each of those lines is sort of the trail that's left behind by a particle, just a point, as it's moving around in space. And the force-directed graph layout idea that I said is behind this piece is just that each particle has a series of connections to the other particles. And the movements of the particles are determined by almost a set of like imaginary springs between the two particles that are between each set of particles that kind of forces them to move around over time.
So it's the relationship between each particle that then creates the bigger piece.
Yeah, final structure that you see is sort of the particles originally are laid out in a very simple structure of circles, but that is not a very natural way for them to be, given the forces on the springs between them. And so what you see in the final result of a piece is the process of those particles finding from that initial set up a more natural way for them to coexist in ways that satisfy the forces between them.
So then in a sense, each output is the most natural way for those particles to exist together.
Yeah, and in fact, it's more like a history of those particles finding the most natural way for them to exist with one another. You see the original way that they start, but you also get to see the whole process of them figuring out where they should be.
It's really beautiful. Does this happen in nature?
Oh yeah, I guess in a lot of ways there are a lot of like analogies to different organisms sort of acting as forces on one another and kind of responding to one another's movements and pulling each other around and finding some natural configuration to rest in.
There's definitely a poetic relation, right? Or some sort of poetic resonance to all of this. But this sounds like something that I believe James Patterson and Casey were talking about in their work, cellular automata, and this sort of these natural structures that we can mirror with math, but in nature it happens just sort of randomly. So I'm wondering, in your practice, how do you think about randomness as someone with such a strong math background, and you create these systems that are very tightly contained? When you think about randomness in your work, what do you think about it?
That's a great question. I mean, there's so much to say. Ultimately, long form generative art, at least, is about rather than defining a specific piece of or rather than creating an aesthetic statement, you're sort of creating a probability distribution over aesthetic statements, right? The whole thing is itself sort of just one big random distribution that each iteration is drawing from. Yeah, in my practice and the way that I use randomness, I think a lot about what different random distributions should be bound to each variable. Everybody knows kind of the uniform, 0 to 1 or whatever. But, there's exponential distributions. There's all kinds of different distributions that you can use. And so I spend a lot of time kind of tuning, exactly how should each parameter of a piece be kind of chosen, and what shape should the random distribution have.
I never thought about randomness, like the aesthetics of randomness, but I guess that really does come into play in a sense. What would you want someone without a technical background to understand about your work and to see in it?
I guess from a non-technical perspective, I still think that sort of understanding that idea of these different sort of independent little agents all sort of negotiating and trying to find a sort of natural, trying to find a way to coexist, something that works for all of them. And yeah, just sort of an exploration of sort of movement and the emergent dynamics that come from a bunch of little independent things trying to all do their own thing. I'm very much, I see myself as like an experimentalist. I'm trying to do something new and innovative with every new project. I really like to break new ground and to do things that nobody has ever seen before.
So now that this piece is complete, what are you thinking about now?
Oh, I've got some pretty exciting stuff in the works. Yeah, not much that I can talk about, but I have a lot of things coming.
That's really exciting to hear.
It's rare that I'll do representational work. Like I said, I'm intending to do something entirely new with every piece, and so most of my work ends up being abstract, and I'm not really trying to make it look like anything in particular. I'm just kind of following the feeling of, oh, that looks really interesting, and I haven't seen anything like that before. And so kind of the associations that people draw, it's always really wonderful to hear from collectors and from people who appreciate the art, kind of what they see in it. But for me, it's really just about chasing that feeling of like aesthetic novelty. And I'm not really normally going for sort of a relation to anything pre-existing in my work.
I'm curious if there are any mathematicians that you're particularly fond of.
Oh, that's a great question. I think John Conway of Conway's Game of Life, which I assume everyone has heard of. Aside from his work on the Game of Life, he just had a very kind of playful spirit in math and in the way that he approached mathematics. And yeah, I've always appreciated mathematicians who kind of approach things from a very playful perspective, because that's what I try to do with my art. and a way I kind of see generative art just as sort of an expression of kind of the beauty of pure math. I think of math as a very like playful activity in a lot of ways, and I think the sort of experience of mathematics that people get in school is very rote, and it's about kind of memorizing formulas and learning the exact rules. But the way that new discoveries are made and that interesting things are done is by playing around and inventing new rules for yourself, and coming up with games and things that people have never explored before. And so I think that perspective on looking at math that creative coding really embodies is really something special.
How do you think about the title of the exhibition in terms of your work?
I guess in a way, like I said, as the piece is a bunch of small little agents, each kind of following their own rules, and trying to find a collective truth among all of them, something that works for everyone, and sort of acts as like a something that the whole system can settle on and agree on.